much, everybody. I know it's been a long day of amazing talks. I'm sure you're all desperately trying not to forget everything that you've learned already, so hopefully I will not bore you to sleep right before our amazing closing keynote. So I'd really just like to take today to kind of walk you all through my journey in figuring out how to measure performance in Ember, because this is something that I spent a lot of time on last year, and it really was an eye-opening experience to figure out how to do that, and I want to show you all how easy it is for you to go down that same path now. So when we were working on performance at Twitch, we thought about, like, okay, we don't want to just optimize performance for the sake of performance, right? We wanted to come from the standpoint of performance. When it's not a great performance, it's impacting your business metrics. A really obvious one is if your page loads slowly, it's going to increase the bounce rate of your users. That's obviously a bad thing. There are a lot of other metrics that you can track performance to. So when you're thinking about improving the performance of your application, you want to be thinking about how it affects the bottom line of the metrics that you care about, rather than just saying, oh, our performance needs to get better. Let's set some arbitrary number and try to hit that goal. The other thing that we started from is, like, we had a lot of back-end instrumentation already. So we had a lot of opportunities to optimize that we could already look at based on the data that we had. However, that was only half of the story. With no idea of what our performance on the front end looked like, we didn't really understand what our users were experiencing, right? We had no idea when they pull up our site in their browser, what that experience is actually like. We could say, okay, well, this API is slow, but what pages is that API even used for? Like, what features is it used for? What is the actual impact? Are there other things that we're doing in the front-end application while we're waiting on that API, and maybe the experience isn't as bad as that slow API indicates? We had absolutely no idea. So we really wanted to dig in and understand what the real-world user experience was like. So that's when we started thinking about web application performance. But really, we didn't know what that meant. And if you were to go and Google right now and Google web application performance, you're going to find a bunch of different terms. They're all valid, they're all important, but they all mean different things. And if you were to only focus on one of them, again, you're only going to get part of the story. These are all important terms that you should learn and know and figure out how to measure. But at the end of the day, when we were talking about having a user-centric understanding of our performance, we decided to focus on something that we called interactivity, or user-perceived performance. And the idea there is that when you have people coming to your application, they're loading a page, and they have certain features that they expect to interact with, or content that they are intending to consume. There may be other things that are loading in the application, but there's usually like one or two primary purposes that they've come to the page, and you have certain components that are loading that primary content. And so when we talk about interactivity, we're talking about how long does it take for the user to have the perception that they can interact with the app for the primary purpose that they came there to do. So you're really narrowing down the scope of, we're not just saying how fast does it take to load everything, because we're dealing with single page apps. So there's always going to be a lot of things going on, and you really want to focus on, like, what are the critical aspects of the page that the user cares about. So we started thinking about, okay, how could we actually measure performance? Well, there are a lot of third-party tools out there that you can use to get started with this. One of them is called PageSpeed Insights. It's by Google, and you can go there and type in the URL for any public-facing website, and it will print out this nice report for mobile and desktop. It'll give you an optimization score. It'll give you some suggestions for how you can better optimize your page. Another one that I really like is called Web Page Test. Web Page Test is like the more detailed version of PageSpeed Insights, in that, again, you can feed it any URL. You can tell it to run tests against certain locations, devices, browsers, internet speeds, and you can have it do multiple test runs, and then it will report the median results across those test runs, so you can eliminate variance. It'll also grade your application across a number of different contexts. You can see here that my website is really, really bad at caching static content. So that's probably something I'm going to work on after the conference. But another cool thing that it does here, you can see at the bottom, is it shows you this waterfall of all of the different network requests that your application makes, along with screenshots. And there's a lot more detailed information around that you can dig into. So this is really great for debugging different aspects of how your page is loading. The third one I want to talk about here is Lighthouse, and this is actually built into the Chrome DevTools. If you go to the Audits tab in DevTools, you can run this on any page that you have open in Chrome, which is really important because the first two that I've talked about are great if you have a public-facing app. But what if you don't? What if your app is only available to internal users, or what if it hasn't even launched yet, right? So you can pull up the internal or local version of your app. You can run it in Lighthouse. It'll give you the score across performance, accessibility, best practices, SEO, and it'll give you this really nice performance breakdown. All of this is really, really important information. However, it comes with one caveat. When you're dealing with third-party tools, they don't really understand how single-page applications work. They don't understand our rendering pipeline. And so when you're trying to get really accurate data and you're trying to get into the granular kind of data of like which of my components are slowing down my page, you're not going to get that here. You're going to get a lot of the high-level stuff, but it's not going to give you all of the details that you want. And the reason for that is, if you have, say, a rich media application like we did at Twitch, something like DOM content loaded isn't necessarily an indicator that your Ember app is done loading. Sometimes it fires too early, sometimes it fires too late, and you don't really know how these third-party tools are leveraging these different browser events to decide on the numbers that they're reporting. So they're good for some early investigation, they're good for some debugging, but if you wanted to generate metrics that you were going to track over time and really dig in detail, that's not the only approach that you want to take. So that's when we started thinking about, okay, well, what if we could instrument Ember? And obviously, if we can use the framework internals, we can get a lot greater granularity on what we're actually looking to get data on. So the first thing we looked at, the obvious candidate, was the instrumentation package in Ember. It has this seemingly nice method where you can subscribe to render events. However, there is a huge caveat here, which is that using this adds a lot of overhead into your application. Essentially, the callbacks that you would fire from this subscribe render call become render blocking JavaScript. So anything that you want to do is actually now blocking the rendering of your application. In our case, we played around with this a little bit, and it slowed down our Twitch chat system to a crawl, to the point where it was completely unusable. So this is something that you really have to be careful about. Not only that, even if you were to use it, your numbers are going to be wrong because you've added this performance overhead, and there's no way that you could use this in production. So maybe you could instrument your app with this and run it in a virtual environment and get some numbers that are comparable to each other in a relative sense over time, but you're still not going to understand the real world user experience across all of your different users who have different internets, different devices, different browsers, different parts of the world. That's something that we really wanted to get an understanding of. So we started looking at, okay, how could we approximate this data without introducing the overhead of something like the render event? So this is where Ember's run loop came into play. So I want to really dig into a little bit of code here. Feel free to let it gloss over your eyes a little bit, but I just want to show how we approached solving this problem. So the first thing that we did, we started thinking about the life cycles of our routes. Obviously, we want to get more granular than this, but at the end of the day, we want to be able to say, for this particular route, how long does it take to become interactive? So we created this did transition hook, and in the very basic naive case where you have a route that is just rendering some very basic HTML, no Ember components, anything like that, you can just do a schedule once of the after render event and you can have this callback that fires off an event. And this essentially says, okay, we've completed the first render pass on the template, and there's nothing funky going on in the naive case because it's just HTML being rendered. So we can more or less understand that we have rendered this route. Now, obviously, in most Ember apps, you're not going to have that many routes that are just doing static HTML because that's probably not why you chose Ember to build your app. So we have this this other part of this conditional here where we have this check where we're looking for this is interactive method. And that's how we handle the more complex use cases. So if you have a need to define custom interactivity conditions, this is how you would do it. You have this method, is interactive, and we pass in a parameter called didReportInteractive, where you can pass it the name of any component, and that name is formatted the same way you would reference it in a template. And you can see here that we've built this conditional where we said if the right column is closed and the social column, top nav, and box art components are rendered, then we return true to say that the route is now interactive. And the system will periodically check this as components report in to see if the conditions have been fulfilled. And then once they've been fulfilled, then we go ahead and fire off the event and check, create the timestamps to know that we're done rendering this route. So you might be asking yourself, okay, well, how do we actually know that the components are rendered for this to even make sense? So that's actually pretty easy. This should look really familiar. In the naive use case, again, just go back to schedule once after render and did insert element. There are a lot of other ways you can use this. The key here is you want to use this naive use case in the instance where your template is just basic HTML and there isn't anything janky going on. You could instead run this in the callback for a data retrieval. If you have some async behavior, once that behavior completes and the component is about to re-render, you can schedule this for the after render for that pass. Now, again, many of your components are probably also quite complicated, and this use case isn't going to work for them. So we used a similar model where we've basically created an interactivity service that components can subscribe to say, okay, I, like a route, care about my children. I care about waiting for my children to render, and so I want you to check in with me when I'm done. And we've also created a sort of unique subscription ID so that we can identify individual components from other components that may have the same name. So looking at a few examples here, if a component has child components that's waiting on, here's a couple ways that you could write their is interactive. You might have a this.loading Boolean, which may indicate some async behavior that you're waiting on. So obviously, we wouldn't want to report interactive accidentally while we know we're waiting on data. So that might be one way you do that. You'll also see here, in this first example, we're waiting on a component called GitHub project to report interactive. There are actually many GitHub projects in this particular parent component, which we're iterating within an each loop. And so we've actually passed a count in here to did report interactive, saying how many we expect to render. So we actually don't report interactive until all of the child components in that each loop have rendered. Another thing that we've done here in the second example is, maybe you have images that you want to load. And so we actually created a lightweight component wrapper called critical image that just hooks into the image loaded callbacks in the browser and then reports interactive when that's done. And in this case, we had many images getting displayed. So again, we use the count thing. This last line here in this example may look a little weird because we have this interesting beacon colon syntax. This is actually something that we introduced to solve the problem of what if you have a conditional block in your template that doesn't have any components in it. So maybe you are in the other half of the block, you're waiting on some components to render, but in this part of the block, you have just some basic HTML. Maybe it's like a no results state that's not very complicated. You wait for your async behavior and you find out that there's actually nothing to render, so you have this alternate template block. But you still need to know when that's rendered in order to correctly track its interactivity. So what we did is we created this interactivity beacon component where you can give it a unique contextually relevant name, which we referenced back here. And then it will just, all it does is it's just an invisible component that you can stick at the bottom of the block in order to have it report interactive when it's done rendering so that you know that that block has rendered. Now, some of you who are astute are probably wondering why is there a component in this block? This is a great example of people not refactoring code correctly. Clearly, someone added this other component above the beacon after the parent component was instrumented. And in this case, the correct answer would have been to remove the beacon and just have the parent component wait on this recommended friends component to report interactive. It's a nice, easy code smell, though, because you pretty much should never see a beacon in the same template block as an Ember component. So you've got your app instrumented. Obviously, you need to be able to send that data somewhere. That's pretty easy. We just had an extensible tracking service that has two methods for handling component and route events. It also conveniently integrates very well with Ember metrics, which is a really handy add-on for integrating with a bunch of different metric services, as you can see in this example. And here's an idea of what some of the base data looks like. You can obviously add your own application-specific data by extending the tracking service. But for route events, we do a few things. We capture loading events for individual phases of a route's transition. We capture the destination of the transition, since if you have nested routes, you're going to fire transitions for a bunch of different routes, but then only one of them is the leaf destination route. We're going to capture, obviously, the client time for the event. And then this loss visibility that you see here is just a little thing that we added for routes to solve the problem of what if your user tabs away from your application while it's loading. That could actually cause havoc for your metrics because it could interrupt the loading of the application. And so we added this flag as a way to sort of understand use cases when the user had tabbed away for two reasons. One, we more or less threw out those events for our normal data analysis so that we could really understand just what the normal loading experience was like. And then the second one is that you can then look at the use cases where someone tabbed away and understand what their loading experience was like that maybe caused them to think, hey, this is going to take so long, I could go do something else and grab a coffee and come back. So the next thing that we wanted to tackle was developer tooling. You have your metrics being sent off where you can do your analysis, but that's not really helpful to you as a developer when you're building a feature, maybe that, especially if that feature hasn't shipped yet, or if you're just trying to go in and debug your application's performance. You need something where you can, like, on the spot see what the load times of your different components and routes are. So we built this thing where you can just go into the performance tab in DevTools and you can record the page load, and we've marked the performance timeline. So if you were to go ahead and run that, you can see something like this, where you get a waterfall that shows you the route and then all of its child components and then all of that component's children, which is a great way to visualize. In this case, one of those child components was very, very slow, which then caused the parent component and the route to be very, very slow as well, even though the other components loaded very quickly. And then because you're doing this in the performance tab, you can also line that up with your different network requests that are taking place and all of the other information that you can see as far as your JavaScript that's being executed, so that it's very easy to tie the waterfall of information to different things that you could use to debug your application. Also, conveniently, if you were to decide to turn this marking on in production, it shows up in things like web page test. So you can see there along the bottom, all of these route initializing and component initializing events are shown there automatically in web page test. You don't have to do anything. Web page test just sees that you have some user timeline things that you've marked, and it automatically includes that in its report. And I want to go back and point out a few things that I found interesting here, which is if you look at some of these events on the bottom, you'll see that we have a bunch of these component initializing events starting around 1.85 seconds. But if you look at the load time that web page test reported, it was about 1.2 seconds. So this goes directly to my point I made earlier about why third-party tools maybe don't understand what you're doing, especially if you have async behavior that you're rendering weights on. However, if you look at some of these other numbers, visually complete is about 2 seconds. Fully loaded, it says about 2.17 seconds. So maybe as you instrument your application more, you'll understand that maybe those numbers better correlate to how your application works. That's something to keep an eye out for. So you don't have to do everything that I just showed you. This talk is about how it's easy to measure performance in Ember. And that is because all of this architecture has been published as an Ember add-on called Ember-Interactivity. You can check out the demo at the link there at the bottom of the slide. It is hopefully well documented. So definitely feel free to check it out. That is something, that's your homework. But let's talk about what did we actually learn from this process. So the first thing is that it's important to define the critical path. If you want to start thinking about interactivity, you are thinking about what are the specific pieces of the page that the user cares about, which means that there are some parts that they don't care about. So once you've defined the critical path, it opens up some strategies like maybe we could actually defer the loading of non-critical components so that they're not interfering with getting the most important parts of the page loaded. Also, there's the obvious one of being able to identify bottlenecks. Once you know what your critical path is, you can figure out what the slow parts of that is and maybe do some optimization. Ultimately, the thing that I really want you to remember here is that when you are thinking about real-world user metrics, you are doing something where any improvements that you make across your entire stack are going to affect those numbers if they are improvements that you should be making. So, you might move the numbers on some of your back-end instrumentation, but if it doesn't move the needle on your real-world user metrics, you haven't actually done something that your users care about. You haven't actually accomplished anything other than making yourself feel good for having optimized something. So here's what you can do to move forward. Go back to your companies, to your apps, and figure out how to work on performance. So first of all, don't just use Ember Interactivity. It's a tool. All of the tools I've talked about today are helpful, including the third-party ones. Do back-end instrumentation. I'm not saying back-end instrumentation is bad. Use as many tools as you think is necessary to get a complete picture of the performance of your application, front-end, back-end, the whole thing. But always make sure that you are thinking about how to capture real user metrics so that you understand what your users are experiencing. Use framework-aware tools for more granular data when you're working with your Ember application. In addition to Ember Interactivity, there's a number of other good ones worth checking out. Ember Perf Handlebars, Ember Perf Timeline. Definitely recommend looking into those. This slide pretty much just speaks for itself, so I'm just going to leave it up there for you for a sec. And that's all I had. So if you want to check out the slides, there's a link there. They are already available. My name is Jordan Hawker. You can find me on Twitter and GitHub, and I am also available for work. So if you want to come work with me, if you enjoyed the talk to me at the after party or check out my resume. Thanks.